Hey everybody, welcome. My name is Crystal. I'm so excited for y'all to come out and watch our tech talk today. We have a very interesting individual and I'm so excited to introduce y'all to him. His name is Sean Whitesell. So excited. He is a senior cloud architect, Microsoft MVP, and he's a user group leader. He is also the current president of our Telsa.net user group, and he has been since 2009. So he's been there up and running, keeping it strong since then. He's also an author of the book Pro Microservices in .NET 6 with examples using ASP.NET, Core 6, Mass Transit, and Kubernetes. So super excited. I'm going to step away so y'all can hear him talk. Welcome, Sean.
Thank you, Crystal. I really appreciate it. I'm very excited to be here. This is a unique opportunity for me, so I really appreciate it. Today, we're going to talk about microservices. The easy way is the wrong way. The real goal about this talk is to show that microservices architecture takes a lot more consideration than you may expect. It's not as easy as you may just assume as you're jumping into this, and hopefully not thinking this as a buzzword type of development. We're going to go over what are microservices, why you should use them, when should you not, and some of the challenges that go with it. And then we're going to do a high-level decomposition example and mentioning a little bit about domain-driven design. So we'll jump right in with what are microservices. And a lot of people have their different definitions of a microservice. And there's from Sam Newman to Martin Fowler, etc. I decided to jump in there and I'm going to offer my own definition on that. And that is that a microservice is simply a tiny monolith with a tight focus on a domain. It's not about size, it's about focus. The idea is that it's not about the amount of code that you throw into it, as it is a tight focus on that domain that you're trying to serve with that functionality. And we're going to dive quite a bit into that with this talk. Some of the main tenets about microservices are that they are independent applications. They need all the love and support as any other application, but they need to be independent, as well as that they communicate over a network. And we'll discuss that a little bit on various ways of that type of communication. Also, they need to have a single responsibility, meaning that they should exist for one reason and not multiples at the same time. If you're going to have a microservice that serves for your accounts payable type solutions, it shouldn't also process insurance claims, things like that. It's best that a microservice is owned by one team. That way you have a focus on the support and the support structure and the development structure of that microservice. They are to be individually deployable so that they are loosely coupled. And we're going to discuss a little bit more about that here in a bit as well. And moreover, it's more about an architectural style than it is about programming specifically. Obviously, a lot of programming is dealt with in microservices, but to begin with is more about architecture. So generally what you see is with your monolith, you have a collection of functionality all grouped together and it's a single deployable unit of code, be it multiple files, etc. But it's just a collection of multiple business functionality all in one. And generally, we build out microservices to when it's time to move out some of that functionality from that monolith, or if we're going to add new functionality. And rarely will you do a total migration. Now, that has been done. We'll discuss that in a bit, but rarely do you have the need for doing a total migration. So why should you use microservices? And this is one of the keys I really want to drive home. If you get the kind of this feeling that I'm going to try to talk you out of doing microservices, you're right. Even though I've written a book on them, the idea is that don't just jump into them thinking they're going to solve all your problems. They're not. It's best if you take the approach of having a microservice that's going to help solve your problems in a quicker, but also safer way and add some stability and not hurt the stability of the current monolith if you're pulling from one. Generally, what you'll see is that the boss comes in and says, "Hey, I've got this great idea. We need to get this done, and we've already sold this idea, and we need this done in 6 months." You come back and say, I'm sorry, the monolith is so fragile, we can't do this, but we can estimate it. It's going to be a month to 15 months kind of thing. Sorry, a 12 months to a 15 months kind of thing. Well, then you've got differences of timeline, and it's just not suitable. In those cases, you're more likely to add a microservice to serve that functionality and then changing the monolith just enough to help solve the problem. And as well, that microservices has some other tenets along with them, such as team autonomy. With microservices, it allows you, the team, to choose the best language for the job. For example, C# is great, but a lot of people choose Python for doing analytics. So if we're going to do a microservice to serve and process analytical data, you have a team working on that. It's probably going to all be done in Python. And but allows the opportunity, because they are independent applications, that they can be used, with the right programming language for the right job, as well as you can have a team focus on that microservice, certainly since it should be with one team owning that microservice. And if you're doing anything like Agile or Kanban, that works very well for the development of microservices. And before I get too far along, if you have any questions, be sure to post them in the chat, and we're going to get to them there at the end. I look forward to your questions. As well, service autonomy. A microservice should provide a single responsibility, in meaning that, like I mentioned earlier, if you're going to do accounting, maybe it's accounting, but maybe it has to split and become accounts payable versus accounts receivable. Just depends on the amount of business logic that you're trying to serve in that microservice. Very simple type microservice with just a very simple amount of business logic. The accounting microservice, for example, may serve you very well. If it grows larger than that, you may look to needing to split that out. But as well, they need to be deployable without other services. You want to be very careful of your coupling of your services so that although they may be tied together at a business process level, they're not tied together at code level or data schema, which we're going to talk about a little bit later as well. They should be deployable without requiring another service to go with them. As well, scalability. You can, with your microservices, you get the choice of how it can scale versus any other microservice, or even how your monolith is scaled. And and along with that, you get your choice of servers. If you're going to use Azure, for example, maybe you can run on some Linux boxes and have certain size of CPU and RAM, as well as maybe a Windows box on a different type of microservice, depending on what your needs are. It also provides fault isolation. The idea here is that if you were to visit Amazon and you are looking at a page that you've pulled up, and you see that the product description, you see the price, and you see suggested items, you see that item compared to other items, as well as reviews, etc. And so much of that page is fed by microservices. But the idea here with the fault isolation is, what if that item, that page pulls up, but none of the reviews do? Well, that doesn't prevent you from buying the item and putting it in your cart, etc., right? So uh, by using certain microservices, you can have some of that different isolation so that even though one piece fails, other business logic can continue on. And I mentioned too that there are companies that have done total migration from a monolithic type approach to a total microservices architecture. And three such companies are Amazon, eBay, and Netflix. Now, they didn't do this just straightforward and it was easy for them, not at all. In fact, these companies have mentioned where they've had to kind of go back and revert on some changes, put out some ideas, and revert, redo it again, etc. So they're definitely not without their troubles, but they did come to the conclusion and where they had to have a total migration out to microservices. This is generally not going to be done. You really shouldn't need to do this, and try to stay away from it if you can. And here's exactly why. So let's discuss why you should not do microservices. Well, plain and simple, they're hard. And now I say that is it sounds like a cop out, but at the same time, good programming is hard as well. But the point here is that there's so much to microservices that you really want to have a good approach to them. For example, if your monolith is simply too small of a code base, you're probably better off throw some feature flags in there, scale it differently, and change what use those feature flags to change what business logic is actually being processed in those different instances that you've scaled. If you have a lot of coupling, you're going to have to spend a lot of time refactoring so that when you get to a spot where you are pulling your functionality from a monolith out to a microservice using something like the strangler pattern, then you're going to have to spend a lot of time refactoring to uh, have that availability just to pull things out anyway. And a lot of times you'll start pulling functionality and then you pull more functionality, you pull more functionality out, you end up with yet another problem. If your team is unwilling or just not ready to do microservices, you're going to want to not jump into them too fast. Make sure you're reading up on them and be sure to research a lot of what it takes to do the microservice for you specifically. It needs to be there to solve your problem, not be there just because for the sake of being there. Have a support structure. Every microservice is an independent application, which needs all the love and support as any other application, including a support system. And as well, that they are very expensive in time and money because you're going to spend a lot of that trying it out, finding out what works for you, having that growth pattern. You can't just take some functionality out, go pop it in as microservice, and you're good. Generally, you're going to have a lot of tight coupling that goes along with that, and you're going to have to work on breaking that apart. So, to discuss some of the challenges that go with microservices, like I mentioned, they're not cheap. You definitely going to want to have to spend some time and money on learning and investing on the trial and error, dabbling to find out what's going to work for you. And where you may be expecting you can just do a network call to an IP address, this is going to be challenged now, where you may need to look at using messaging. Or do you do RPC calls? Should you do synchronous or asynchronous? What about a pub sub messaging pattern, etc.? You may look at or think that you can copy files out to a server and that's your deployment method. Really, since a microservice is an independent application and it needs its own CI/CD per microservice. So have a continuous integration, continuous deployment pipeline per microservice. Along with that, a single code repository. Since it is an independent application, it needs to be treated as such that goes with the CI/CD pipeline and that code repo. Now, you're also thinking, well, I can develop a microservice, it's just code base, but why do I need to worry about networking? Because now, since they communicate over a network, now we need to discuss and understand how do they communicate and the need for different load balancers, etc. And understanding how a load balancer of choice and how that works on the network stack. And so this is where that OSI model comes in, and you need to be more aware of layer 4 and layer 7. We're going to discuss that on the next slide. Security. Now, you may not have worried about your code modules and the security in between them. Now, this is a much bigger deal. Imagine you've got microservices running on a flat, so a private network, but you decide that you're going to bring in maybe a NuGet package or an NPM package or something like that. Now, you may not have written that package, so you're going to bring that third-party package in. How do you know that the NuGet package that you've brought in is not actually listening to the network and trying to send data out to another location? So imagine, for the sake of this, that microservice is processing your paycheck. Now, do you want to protect the data that's going in between getting sniffed, as well as, and I mentioned OAuth right here, governing who can call that microservice? Just because it is a service that has an endpoint on a network or a messaging does not mean that it should be available for any other code to call it. There could be an abuse of that execution there. Again, take kind of that approach that if it's processing your paycheck, you're going to want to protect that. And then there's the idea of common code, where we have or shared libraries that maybe even if they're built in-house, and we got these microservices that are sharing that common code between other microservices, maybe between the monolith, etc. But we're going to show here in just a bit, or go through an example of why that's actually going to keep your services tightly coupled and kind of breaks that rule that a microservice should be independently deployable from other services. So we're talking about the OSI model, that Open Systems Interconnection model. This is a simple 7-layer diagram, if you will, about network stack. And meaning, so if we start with the physical layer, this is where you're understanding about copper, or maybe it's fiber, and how that kind of medium is used for the network communications. And then as data packets and that data is coming through on those communication, it's going to come up to, for example, to an IP address. Well, this is where your layer 3 comes in. So maybe it's an IP address, maybe it's a ICMP for ping, for example. And then you have that type of data, which is TCP or UDP, and that's that layer 4. Then we go all the way up to layer 7 for HTTP. Why does this matter? Well, as we have our multiple instances of a microservice and we are scaling those microservices, well, you don't want to know of just every IP address out there, certainly when there's already systems like a load balancer that can handle that and do that for you automatically. Well, if you're dealing with IP addresses because you're going to do an RPC style call, then you're going to have a load balancer that operates on layer 4. And Azure Load Balancer, for example, works on layer 4, whereas in AWS is the network load balancer operates on layer 4. And then the HTTP matters, and that comes in if you're going to work with maybe like the Nginx load balancer, for example. And also just to make sure that you're familiar with, like when I say layer 7, if you imagine like MVC, that model view controller, they always leave off that one letter for R for routing. Well, as data gets routed and that request is getting routed, it's going to be routed at layer 7 to the controller that's handling that request. So that's where a lot of that communication comes in on layer 7. So for us microservices developers, we need to understand the communication types that are available and what you might be using. So like I said, with layer 4, you got application load balancers, or the Azure load balancer, and then layer 7 for something like Nginx. Okay, here's a quick scenario of us talking about the tightly coupling of common code. Imagine that 2 different teams working on 2 different microservices, and they're both using the same NuGet package. Now, the first team needs to evolve its service, and so it's going to make a change to that NuGet pack so that it can get its next version out. But the problem is if there's a time when that change breaks something for the other team with that service, and now that's preventing them or inhibiting them from making their next version and getting that out. So now they're having problems and have to adjust for their issues. So the suggestion here then is to duplicate code. And I know it sounds kind of weird. It's very contrary to that DRY principle. But to be honest, the DRY principle applies at the code function level versus the architecture level. So in these kind of cases, you do need to go ahead and duplicate code and split that out. What code would you split out and duplicate? The code that needs to evolve independently. This is the key thing. So when you're duplicating code so that one microservice can evolve independent of another microservice, then copy that code out, bring it to its own package if need be. So even though it sounds like, yes, it's duplicate code, it's not for very long. It's going to evolve and allow that microservice to evolve as well. So the gist is separate that code changes to their own package. for the service that needs it. So let's touch on one more thing right quick. When I talk about that central NuGet package, who owns that? So this is the other problem, right? Is which team actually owns that central NuGet package, and are they responsible for the changes, even though it may be for another team? And therein lies one of the other problems that has to be worked out. Okay, so presented multiple different challenges that go with microservices, and you've decided to go ahead and design out build out a microservice anyway. So you start carving out functionality from your monolith, and you start building out your microservice. Then you find out that there's other dependencies for that service, so you start bringing it over, and you keep bringing more of that functionality because there's that coupling, and then you find those dependencies. And as you're bringing them over, you didn't make another microservice; you built yet another monolith. So now you're in this and have this problem of a distributed monolith. Now, here's the problem. If you stop here, this is a problem. You've got now two monoliths that you're going to have to deal with, and you're probably better off to stick with the first monolith, add feature flags, help control execution paths so that they can be scaled in various ways. But if you are here in this position where you do have this other monolith, but you don't stop here and you continue carving this out, you still have your user stories to continue carving this out so that it becomes a microservice that it needs to be, that's fine. This is simply a hop on the road, and it helps you understand a lot of your dependencies that you have. So we're going to switch gears as well to another challenge with microservices, because one of the other rules with I say rules, it's not my rule, but it's a rule that I've heard, and I disagreed with it at first until I understand the real constraint here. The rule is that if a microservice persists data, then it needs to have its own database. Now, there's kind of variations on the implementation of that rule. Is it its own database or an own database server? That's debatable. But why should it have its own? This is where I disagreed at first, because much like my scenario I'm going to walk through, this is where I was at. I had all these applications and they were working with a centralized database, usually SQL Server. And so to just carve out another database didn't make much sense. And of course, a lot of DBAs are against that. It's yet another database they have to support. So why then is the rule there that suggests that you carve out to another database of some sort, some kind of implementation for a microservice? Now, I'm adding the distinction of a microservice that persists data. Not every microservice has to persist data. Some there's just for on-the-fly calculation, something to the example. So let's look at this example right here. So if I've got a database and I've got tables for things like accounts, customers, orders, order history, parts one, shipping history, logging. Oh yeah, that parts table. Yeah, so here's the problem that you generally see. With multiple applications evolving, and so does the schema of the tables. So we're constantly adding columns on there. And then at some point, well, something didn't fit just right. So somebody carved off and said, let's make another table. And of course, we are great with our naming conventions. So it's parts one. I doubt I'm the only one that's ever done that. But that right there shows the problem. Applications evolve, not surprising. The database has to evolve, the schema has to evolve, and then comes the challenge that now if I've got multiple applications using the same database, the same schema, that you're going to be in a position where some of the schema changes are going to break something for another microservice. Something that allows inhibits an application from evolving independently. There's the problem. So the solution, this is where I had trouble with this too. Duplicate data. Now, I was in the same boat. That sounds like a lot of extra work. Plus, if I duplicate data, which one's the single source of truth? Because then there isn't one. Sort of. Here's what we're going to do. So imagine in our scenario monolith, but we're carving out other microservices. So I've got a parts microservice, and I have an orders microservice that is reliant on parts information. And then I'm going to go so far as to build a shipping microservice that has dependency on order information. And I suggest you to copy and duplicate data so that now, obviously, you can duplicate data. Another example is if I have microservices talking to other microservices and one's calling the other to get that data on the fly. So it's not stored, but it's done on the fly. You can do that. You could have a chatty network in that case, and you could have additional latency where one microservice cannot finish its processing until that other microservice that it's calling completes its results, and hopefully doesn't time out or have its own issues because it's an independent application. So if we do duplicate the data so that the orders microservice has duplicate information about parts, what would we duplicate? So if we dig in a little bit to that parts database, and we look at the kind of data that's stored with that single source of truth about parts, you got an ID, a natural key, all this other parts details that describe the part, etc. Even down to the manufacturer, when was it created, what's the manufacturer's part number, is there a discontinuation, what was it replaced by, etc. Well, we don't need to duplicate all that data. So an order only needs just enough information about the part that it can do its job of being in order. It doesn't care about manufacturing, information. So now if we duplicate just a subset of that data to its own database, then it can have a record of everything it needs. And certainly if something about that single source of truth of the parts were to change, then you can decide, does a order from 3 years ago referring to a part, does that data need to be updated as well? What if, for example, that it's an existing order, it's not 2 years down the road, but it's an open order and there's a typo? So this is where we could use something like messaging to help keep our data in sync. So now imagine, if you will, we've got an administrator using the website through referring to the monolith application, and the administrator updates and adds a part. Well, then that message is going to go to the parts microservice, and nobody else is needing to know about this. So it goes to the parts microservice, and it adds that part information and all the details to that database. And then somebody tries to buy that information, they've bought it and it's getting ready to be shipped, and they call the administrator and said, hey, by the way, there's a big typo in your description. Ah, okay, well, let's go fix that. Goes to the system, edits, and now there's a message going to multiple services. So this message could go to the parts microservice that says, I need you to go and fix this typo. And you get to dictate the message that you have in the message format, etc. But the idea is that you can have the parts microservice reacting to that message that says, I need to go and fix this typo for this part. The order microservice can also react to it and says, well, do I have any orders within the last 2 years, something like that, where I need to go and update that typo as well in the database? So now, by one event, one message, multiple microservices can react to it independently of each other and handle it individually with their own business logic to have that updated. Another way that you can do messaging is with this. And so instead of parts microservice, what if I swap that out to payments, for example? Now, let me give you the scenario that something I do is I have a secondary checking account, and it's just for internet purchases. The idea is if I go and order something and off some website, but that account gets hacked, well, the most they're ever going to get is maybe a couple $100. It's not the account where my paycheck lands. So I will often go to something, let's say Amazon, for example, and I go and buy something off of Amazon. And so an order created event occurs. The order microservice has picked up that information and fires off an event. And now it's going to go to payment, and the payment tries to get the funds from that account, and then it says, wait a minute, there's insufficient funds. Well, I bought some stuff out of that account. I hit zero. Or maybe just less than the amount that I'm getting ready to buy, and I forgot to move some monies over there. So now I have this saga type message, so that's created, and it's working with the microservices in those different types of domain events, such as insufficient funds. Now, does it go and delete my order? No. Instead, another process kicks off. It emails me and says, hey, if you will update your payment information on this, we can go ahead and finish your order. Okay, great. I log in and I moved some funds over there. Maybe I choose a different account, whatever. And then I update this information. So it updates that saga. And that saga message is essentially a maintained state for that order that's actually across multiple microservices. So this way, the microservices can still evolve and exist independently, but yet have the transactions that are connected at a business purpose still connected through that purpose of the saga. So then, I updated my funds. I said, try this again. It goes over to payments. It tries it. Yep, it succeeds. This is great. Updates the saga, and now shipping can proceed with what it's getting ready to do, package up the order and get that out. So get ready to shift gears. So let me summarize on this piece right here. So there's different type of aspects where you want to be very careful with microservices that can prevent them from evolving independently. One was we talked about the code level. So if you're sharing code between modules in a monolith, when you pull out for a microservice, you're going to start seeing some of that contention of that code. And if it prevents any kind of service from evolving independently, then go ahead and duplicate that code. And again, it won't be duplicate for very long, but it allows that to evolve independently. At the database level, you have a schema connection where you can still have that contention that can prevent a service from evolving independently. So one of the ways we do that is we split that database out so that you have, maybe it's a different database, maybe it's a different set of tables, or a database a schema level where you can change and manage the permissions on that. Those are various ways. It doesn't have to be a database server completely new. You can work that out to what's best. Also, one of the benefits of this is, what if the monolith was working from a relational database and I have microservices that now doing what they need to do? Maybe you don't have to stay with a relational database. Maybe it makes more sense to use something like a Mongo or a Cosmos DB than something, or DynamoDB, for example, that's a non-relational database. So by splitting up your database concerns, it allows you to have independent applications, those microservices that can evolve independently and have a database choice that differs from where it came from, allowing, again, for other options with that. So it's definitely a pro if you're willing to do that and carve out the data to get that done. Now we're going to shift gears because now we're going to talk a bit about decomposing a monolith to a microservice. Now, I do need to stay high level on this because this is extremely involved. In fact, this is not just another talk to itself. This could be a workshop a week long and still not get done. There's just a lot to this. And by the way, again, I'm going to mention this again. If you have any questions, post them in the chat. I am kind of flying through this quite fast. with the assumption that you'll be able to replay this later, but I definitely want to have enough time for your questions. So definitely add those in there when you get a chance. So let's take a look at that monolith. Now, we're going to go back and we're going to extract out some functionality out to its own microservice. Right, and when do we do that is usually when we need to evolve that code module, that piece, but we need to pull it out so that it can evolve independent than the rest of the monolith. And then generally what happens is when we look at that and we look at the functionality of those code pieces in that monolith, the boundaries are not usually clearly defined. In fact, I've yet to work on a just a perfectly well done monolith. Generally, by the time we get to here, it's usually called monolith hell because how interwoven those code dependencies have become. So if there's items in there that lack good dependency injection, then you may need to add those in because that's going to help add ways of breaking that module apart and providing ways where you were calling this module, now you're calling a proxy to call this from the monolith over to a microservice where now it exists and handle that response coming back. So you're definitely going to have to spend some time refactoring. So suggestion on what you should do if you're going to start carving out code functionality from a monolith. Start small. And I say this because there's much involved in the setup of a microservice, regardless of the amount of code that it has, that you still need to spend time building that infrastructure, your code repository, your CI/CD pipeline. How are you going to test it? Do you have a team set up for this? So you still have so much to put in place before you can really get going on this. So start with a small piece of logic just so you can work on building up these other pieces that go with it. Okay, so let's go through a scenario. Now, I'm going to kind of mention a little bit about some domain-driven design concepts. This is not the only way of doing microservices. Using domain-driven design, DDD, is a fantastic way of working with microservices. It's just not the only way. So I have this fictional company, I hope it's fictional, she has been when I created this, called Wham Bam, and they make fidget widgets. They're a production company. This is a key piece here. The main thing they do, as in their main domain model, is production. And this is where they're going to take physical things, assemble them to make a final product, and get it out the door. Now, which is that core domain. They have the subdomains, purchasing and shipping, that are there because for the production domain to do its job, it has in a physical sense, they still have to purchase raw material. So this is where the purchasing department comes in. Now, I want to say that very carefully. I say department, but a domain model does not have to line up with a department. Be very careful with that. And there are domains as well that go with this, and such as accounts, invoicing, returns. And notice that I call them generic domains because the focus is on that production. What if this example was actually for an accounting software company? They make accounting software. Well, then that core domain would be on accounting, not production. So as you focus in on and understanding the domains and the domain models, that's really going to be dependent on the business and the business logic problems that you're really focusing on and trying to solve. I mentioned event storming here. I highly recommend this workshop called Event Storming. Alberto Brandolini is the creator of Event Storming, and he's got both a blog post out there, website with blogs on there, plenty of videos out there, but also a book that he's, I believe, finished by now, working on event storming. Highly recommend it. Essentially, an event storming workshop is where the subject matter experts get together with the developers so the developers have a far better understanding as to how business processes are actually being done. Rarely have I ever seen that a company is going to change their ways to what is being developed. Instead, it's the other way around. The developers are building software solutions to help solve business problems, business processing problems. And those subject matter experts help us developers to understand how things flow, to whom does it touch, etc. If we're going to create an invoice, who does that affect, etc. An event storming workshop is a way to really get a better understanding on those workflows. Okay, so we're starting to look at, and for this example, I'm going to focus in on the purchasing domain model and the production. And as we go and we're starting to look into some existing processes and existing code, we're looking at and we're noticing things like the vendors and parts for purchasing as well as for the production. They've got order and products. And one of the things that we notice is that as we're analyzing this and we see there's a grouping of common functionality. I say common, not duplicate, but common functionality. Here's a group of all the functionality that supports purchasing raw materials. And here's all this functionality production and how it operates. And we're able to kind of draw a circle, if you will, around these items. And that's essentially what we're noticing is called a bounded context. So that bounded context is that kind of that grouping of common functionality in those various pieces that are independent from other areas. But one of the things that we've noticed is that parts. So, well, purchasing has parts and production has parts, but although it's the same name, it's not the same thing. And this is where one of the main tenets of domain-driven design comes in, called the ubiquitous language. And with this comes the suggestion that even in our namespace, to our class names, to our method names, we need to have that properly named so it avoids confusion and has a ubiquitous language applied. So now we change things from parts to purchased parts or assembly parts. Now they make a much bigger difference, knowing that just by context, the name had difference there. And this is where you can get with your subject matter experts as well as any other developers looking at, maybe it's a new person to the team looking at this code and now it's referring to purchased parts. It makes a lot more sense. Okay. All right. So now let's focus in even further, but now I'm going to stay right inside that production bounded context. And now I'm looking at class level details. So now I have a class called order, and it has another class with order line, and in the order has a collection of order lines, and a product class has another class called assembly parts, and there's a relationship there so that the product has a collection of assembly parts. The product represents the final item that's being shipped. This is what got sold and being shipped. An assembly part is, you can imagine taking some raw material and it gets built into sub-assembly parts and then built with other assembly parts to become a final product. Now, we have seen this where code in one class inside our aggregates, the order aggregate and the product aggregate, you may have code that's in an order line class wanting to somehow adjust an assembly part. Maybe there was a special request that has come in to change a detail about that assembly part. Maybe it needs to be anodized or galvanized or something to that effect, right? Something about how that assembly part should be as it becomes and assembled to the final product. One of the rules with domain-driven design is that that class order line is not allowed to call functionality in another class unless it goes through what is called the aggregate root. And since a product is that top layer class of the assembly parts, it is that aggregate root. And the purpose here is that if the order line was allowed to call and change details at the assembly parts class, then the product aggregate root could not help maintain data integrity. Because maybe if you were to call and change something about that assembly part, well, that could have another effect on something else, and you want to prevent that from happening. You want to prevent a negative result on that. So instead, you have that functionality layer class. What if it's not there? Well, then if it needs to be there, then you get with the developers and say, I need you to expose this functionality so it comes at the top layer. But for the purpose of DDD, the idea is that any code in any class can call another aggregate as long as it goes through functionality at the aggregate root level, therefore helping to maintain data integrity. Okay, so now we're understanding some of our functionality exposed by the order and exposed by the product class. And we decide, we can work this together for this purpose. And let's just say this is a possible, notice I say possible microservice. It doesn't have to be a microservice at all. Again, we're using DDD to help better understand how we might create a microservice, but it doesn't have to be one. So now we have a production microservice, and it has a single bounded context in there for that production bounded context, and it's exposing some kind of available functionality at the service layer. Now, one thing we're going to notice is that the bounded context in a microservice can have more than one bounded context in it. But what you will not have or should not have is a bounded context that spans across multiple microservices. Because a microservice is an independent application and a bounded context represents a lot of the business functionality, if it spans, how do you guarantee that the code changes would be consistent and not tightly coupling of the microservices? Now, I say don't do this, but what I'm also referring to is that a bounded context with business logic in there. There is a time when you do want to have a bounded context that does span microservices, but there is no business logic in it. Instead, it's for the purpose of cross-cutting concerns. Things like we have an agreed upon log aggregation tool or a telemetry gathering tool, any kind of thing that is not about business logic, but about supporting the microservices existence at all. Grafana with Prometheus, things like that. That help understand the health of all the instances that are there. Anything like that that needs to be shared across more than one microservice. Again, this is fine because although there's logic there, it's not business process specific logic. Okay, guys, so we went through a lot of whirlwind stuff about microservices. So here's a quick review. Yes, they're hard, so is good programming. I'm not saying shy away from them. I'm saying be careful of jumping in just for the buzzword effect of it. Understand that there's a lot more to discover about them. There's a lot more to learn, to play with, to trial and error. Don't be surprised if you build microservices for multiple months and then have to scrap it. And it's all part of the learning curve. Understand your messaging options like RPC and messaging. Should you do synchronous or asynchronous type calls, etc. And because microservices are independent applications, they need to have all the love and support as any other application. So it needs to have its own CI/CD pipeline as well as a code repository. Be careful about sharing code because it helps keep the things tightly coupled, and you do not want that. Understand a little bit more about networking and how those communications happen, and can help with your scaling. Understand security so that if you were to pretend that microservice is processing your paycheck, you are helping to secure the conversation in between other services, even on a private network. You still want to be careful of that. And even so far as to judge who can call this microservice so that only a permitted other service is allowed to call it. Then we talked a little bit about domain-driven design, using that for carving a little bit of functionality for its own microservice. So we touched on bounded aggregates. Here's some recommendations that I have on Microservices Patterns by Chris Richardson, domain-driven design, the the original book by Eric Evans. I'll tell you the book that helped me the most with domain-driven design was the next one down by Scott Millett and Nate Toon. I call it the PPP of DDD because it's harder for me to remember patterns, principles, and practices of domain-driven design. And Monolith to Microservices is a fantastic book by Sam Newman for helping to understand that transition of what you want to carve out, understanding more details about the strangler pattern, etc. As well, if you are brand new to us and you want to learn a lot more about it, as well as doing some .NET 6, I have my book out, just came out this last January. Myself, along with Rob Richardson and Matthew Groves, are co-authors that helped me get that book done. All three of us are Microsoft MVPs, and even the tech reviewer is the Microsoft MVP as well, and even got Scott Hunter from Microsoft as the forward on that. So with all of that great stuff there, thank you for coming to the talk. I greatly appreciate it. I hope a lot out of it. My name is Sean Whitesell. You can find me on Twitter, code with Sean W. This presentation and others are on my GitHub at SeanW122/presentations. And we do have a meetup. We actually meet twice a month for my user group, and I don't stream very much on Twitch anymore, but on the occasion, that's where I'm at. So with that, are there any questions I can cover?
Thank you so much, Sean. That was wonderful. So much content that you were able to give us within our short time with us. Thank you. We do have a couple of questions. One question that we have here is, how would you implement role-based security either with or without microservices? A little bit of context with that is that this particular team has been dealing with a lot of performance issues due to coupling users with roles with content that live in separate services. So just to restate that question, how would you implement role-based security either with or without microservices?
So I would look at something like a service mesh. Either, and there's another one and I completely forget the name of it off the top of my head, but Dapper DAPR that Microsoft just put out, a distributed application runtime, is great for handling things like that, either with applications, but and more to the purpose of microservices. It has that sidecar approach so that it's a container sitting next to your code as a container, and it can help proxy those kinds of requests. So if you set it up and say you want to do identity management, you can set it up with an identity provider and it will help manage that with that. Along with that, I think it can do OAuth, which is more for authorization. And so after you're working with your identity provider, it'll have that RBAC set up in there and can help judge with that. I would look to doing that first, using Dapper with that DAPR, distributed application runtime. I hope that answered the question for you.
Awesome, thank you. We'll have another question here is, how do you determine the smallest reusable concepts? There's multiple questions, so I'll say all of them and then I'll restate them.
Okay.
So the first one is, how do you determine the smallest reusable concepts? Is it just the database validation or interaction? Is it too small? Then what is the best way to determine the next level scope that consumes the lowest level?
Okay, so the way I'm interpreting that is referring back to how big should a microservice be before it's not a microservice? And I'm going to reiterate, and this is kind of something I touched on right at the beginning, is not about the size of code. So it's more about the focus on the domain. So if that domain this is processing accounts payable, and this is every functionality that's in here is just for the purpose of accounts payable, great, then you're not intermixing with another domain such as scheduling a doctor's appointment kind of thing, or processing insurance claims. Totally different domains. So what's too big? There really isn't an answer. If when the amount of code base that is there starting to span outside of its original purpose of a domain, primary domain, then you're muddying the waters and you're giving it more than one reason to exist, domain wise, and then that should be carved up. So again, it's not about number of lines of code. And if you're going to start pulling something away from a monolith that's doing this, find a piece of code that can tolerate latency. And because you're going across a network call instead of a memory call, you immediately have additional latency. So if you have some business logic that can tolerate, say, for example, a 5 second delay, not that that's average, but something as long as a 5 second delay, then maybe that's something you can start playing with, carve that out, put it to a microservice. If that's working for you, now start bringing over some additional functionality that's still inside that domain. That's what I would suggest.
Thank you. Thank you. Yes, and then those for anybody who did ask those questions, if you want some follow-up questions on the basis of his answers, please just throw it out in the Yammer. We'll go ahead and ask it on here. And then for one of our final questions is just curious and data conservancy, cannot talk today, issue on duplication of data. So user can send multiple updates on parts model to fix the typo. Guessing the definition of bus means those transactions can fail one of the microservices. Is that something that needs monitored as well with the collisions on the use case, on that particular use case?
Absolutely. So although I touched on it, I did not give a complete picture about using messaging regarding microservices. Yes. So if you have a parts microservice and its database and it orders microservice with its own database, then essentially they have their own independent transactions occurring. So if I was to do an update to parts through a message, and then the parts microservice picks it up and updates, and let's say it updates a transaction, and the orders microservice does the same thing. What if the orders succeeds, but the parts transaction fails for whatever reason? So this is where you would have what's called a compensating transaction. And this is where it is not at the microservice level, it is at a business process level. If that message was received and is being processed for the example of fixing a typo and it fails, what does that microservice need to do to fix it? Maybe it retries, maybe it waits, several minutes and then tries it again, anything like that. That is something that absolutely has to be thought of, and is also one of the problems with microservices as an architecture is because they're independent applications, you do not want to have what's called distributed transactions. It's a different subject, but using sagas to help work with capturing that as a whole. Now, in that example with a typo, that's an independent problem where what if versus an order versus along with a payment and shipping, if one part fails, say like a payment did succeed but fails to capture that in the database, then maybe it has to do a compensating transaction and other microservices need to know about it. So maybe we don't ship before that payment has truly cleared and committed to the database, something like that. That's a different type of message. It's a different type of event. And you can do that with sagas so to help keep that intact. So, but it's called compensating transactions. So again, it's to the business process level, trying to solve those.
Awesome. Thank you so much. Thank you so much, Sean. We're pretty much at our time, but it's been such a joy being able to listen to you give your talk. I can tell that you have so much passion about microservices. Oh, yeah. Thank you so much for joining us. Thank you so much, Oracle Cerner, for coming out and joining us. If you have any further questions, please put it out in the Yammer. We will definitely get them over to Sean. Until next time, bye, y'all.